Test. Alright, everybody, hopefully you could hear this. Sorry for the delay in getting started. There are some last minute technical issues, which are always unfortunate when they happen. So first off, you may hear that I'm sounding a little different right now. That's because I'm feeling a little bit under the weather. Just getting over kind of a nasty little cold. So please forgive me if my voice dies out on me here. All right. So, with the plus sides, all right. So. This time to try to improve. I'm on a different computer right now. I'm on my desktop, so you can see the stream is at 1080p quality. I've also switched to using OBS for the first time. So the main point behind that was able to broadcast my voice and the application audio at the same time. So I've got that all set up now. You will be able to hear what Jubal sounds like, as well as my voice. Hopefully, if everything goes right, you can hear both things. And then the last bit of announcement is the source code for Jubal is up on GitHub and is publicly viewable. So if you look at the video description, you'll see a link to the repository. If you want to follow along, you can just open up that link and clone yourself a copy and just kind of look at it. And that is the repo I will be pushing to during the stream as well, so you'll be able to follow all the changes which I'm making. All right, so first thing which I will demonstrate is how you can hear Jubal and my voice at the same time. All right, so actually I'll show you the source code first. So this is just a jack driver for my Jubal engine. Basically, Jack is Analytics Pro Audio API. When you write it, basically you have these callback functions which you must, which will be invoked by the Jack API thread at the appropriate time, and then it's your responsibility to handle those events. So basically, as you can see here, all that this Jack backend is doing is finding out what the current timestamp is for this sample callback period, and that is in samples. And then we call the Jubal engine for this period. And then we attenuate the volume a little bit, just because the Jubal output is coming out a little hot, and this is just to make it a little quieter for the stream. So I won't blast out anyone's speakers or override my own voice or anything like that. All right, so then we have the interactive part. As you can see here, SDL key to note, that's just translating SDL key presses into MIDI note numbers. And then in the body of the application here, we just have a very simple loop. I'm just using SDL to get key presses. Basically, I'm assigning each key on the keyboard to a different note. And then when when I press the key on the keyboard, it will play the note out of the Jubal engine. So as you see, I have key down will cause a note on event, and then key up will cause a note off event of that note. And I'm it's not a repeat because ordinarily when you hold down a key in SDL, it will cause that key to repeat. And I just want to have a simple on or off type situation. Alright, so here's the first demonstration so you can all hear what Jubal actually sounds like. Now this is a very simple one. This is just using a sine wave. So you can see I will just jam a little bit on the keyboard and demonstrate it. Oops. Okay, that's not good. We've got another technical issue here. Okay, so Jubal is connected up. Okay. Let's try that again. Okay. Okay, I'm very, very sorry about that as well. There are just a few issues going on with streaming with OBS for this purpose. Alright, but in any case, okay, here we are. Now we've got it. Got this working again, so I can show you this is what Jubal sounds like. Alright, so okay, so that's only a monophonic sine wave type instrument. Not very interesting. We're going to spice it up a little bit. What we're going to do is we're going to add multiple voices to the sine wave synthesizer. Basically, a voice is the number of voices that your synthesizer has is the number of notes that can be played simultaneously. So we're just going to alter this. Instead of having a single voice, we're going to have many voices. And we're going to use a round robin style voice stealing algorithm. So voice stealing is basically when you have a limited number of notes that can be played at the same time, then what you do is when you want to play an additional note, like let's say your maximum number of voices was 4, and you try to play 5 notes at the same time. In order for the 5th note to sound, one of the other voices would have to be stolen away from their note. So now we're just going to change it here so we have multiple voices. So basically, each voice will have to have all the parameters that are unique to the process of playing the note. So for the sine wave instrument here, that would be the frequency, the current time, and whether it's on or off. Okay, so when we receive a note on event for the sine wave instrument, which is this part right here, first of all we have to assign that note to one of the voices. Oh, I need to change something here in the initialization function. Allocate the space for that. And I'm changing it to voice underscore assign. That'll make it a little bit more clear what it's doing. This is just whatever value is in this variable here is going to be the next voice that will be assigned to. And we're just going to use round robin voice stealing. So basically we just keep incrementing this assign and reset to 0 once we run out of voices, and go from there. Alright, so once a note has been triggered a voice, we have to turn that voice on. And we have to set its frequency. And then finally we have to set the time as well. Now, eventually we will be having a more advanced notion of time once we start adding envelopes with attack, decay, sustain, release. But for now, we just reset the time to 0. And then finally, we mark that voice as used. And we notify to make sure that we note this fact that the next voice that will be assigned will be the next voice in the round robin sequence. And the same thing, once we have a note off of it, we need to find which note which voice is playing that note and turn it off. And to help keep track of this, in addition to the frequency, I'm going to keep track of the note. The note number. And this is just making sure all voices initially are set to off, so that we don't have any voices playing garbage values. Alright, so if that note is in use, if that voice is playing the note, which is the same note which we got at the note off event, that means that we need to turn that voice off. Now, of course, later on, once we are adding envelopes and stuff, then instead of just completely turning it off like that, we would be triggering the note to enter the release phase of the amplitude envelope. But for now, we will just turn it off. And we are not handling control changes at the moment. Alright, and we need to keep track of when we get the note on, we need to make a note of the note. I made a mistake here. Okay. Oh, yes. I need to change the evaluation function here to also change this one right here also to loop across all voices instead of just the one voice like we had before. Alright, so if the current voice is on, then we mix it into the output for that synthesizer. And as you can see, this is just the equation for a sine wave, which is a sine 2 pi ft. So amplitude 2 pi sine frequency and time. Yes, one more. The printf here. Yes, and it's voices, not voice. All right. Great. All right, so now you can, I will demonstrate it, and you can see that our synthesizer can now play multiple notes at the same time. Okay, seems to be another issue here. Well, I will we'll make this one print out the left and the right output so you can see what's going on. Okay, so now it's working. I don't know. There is. All right. Well, in any case, now you can listen to this. You can hear how there are now multiple notes we can play at the same time. And that is really crapping the stream video out, isn't it? Alright, I'll get rid of the printf then. Right. So, I don't know if this is coming across on the stream or not, but there's some issue with how Jack is routing to OBS, because now again I'm not hearing anything locally when I'm playing, but it did just a minute ago. Okay, so now it's working again. I don't know. I really need to work more on this recording setup, but whatever. Anyway, hopefully you heard that and you could hear. Now, with the addition of multiple voices, we could be playing multiple notes at the same time. I think I'm going to just kick this into release mode also. Maybe that'll help some issues. You know what, let me just... I'll stop wasting time on this. It's just recording issues. Alright, so the next thing I'm going to add is a little bit of vibrato to some of these voices to make it... Actually, you don't want to hear that. You want to hear something different than just a sine wave, don't you? Alright. So we're going to add... well, let's make it play a sawtooth wave instead of just a sine wave. So I'm going to make a new function called saw that will generate a sawtooth wave. Alright, so basically one way which you could generate a sawtooth wave is by evaluating the Fourier series. Basically this French mathematician Fourier, he discovered that it was possible to create any sound, or I guess any waveform, just to make it a little more general, by adding up a series of sine waves of different amplitudes. So we can indeed do this with a sawtooth wave by building it up out of a lot of components. Now, obviously for efficiency reasons, you would not want to evaluate the whole Fourier series at once. So you would, you'll use a different technique, but just for demonstration, Um, Alright, so we're just, start off with maybe five sine waves. And I will show you how they get more and more saw-like the more sine waves you add. Oh, and of course, feel free to ask any questions if anybody has any. Alright, so if I remember correctly, the formula for the sawtooth wave is, you know what, let me just double check that to be sure. Let's see, is that in there? Nope. Yes, wavetable. Yes, of course. Multiplied by k. K. Multiplied by 4 for pi. Alright, so 2 pi ft. Actually, we are already passing in a, which should have 2 pi ft already in it, so it will be k times a divided by k. Excuse me. Alright, so first we will do it just with one to demonstrate how indeed this will. Alright, I guess you guys did not really see any of that because OBS crashed. Very sorry about that. I've just been having some issues. Okay. Alright, so here's the sine wave. You can see here. But I'm not sure what's causing the issue. I must be calculating vibrato incorrectly. Alright, so yeah, OBS crashed, so I'm not sure how much we all missed, but I guess just a little bit of a recap. So now we've got Jubal. You should be able to hear it on the stream at home, and listen to this. You can hear we've got a sawtooth wave synthesizer, which can play multiple notes at once. and you can play multiple notes at once. Alright, well that one, but the problem is the vibrato implementation, which I have now, has some problems. So just to show you what it sounds like without the vibrato. Right. Okay, hang on. I know what this problem is. I've got too many voices. Sorry. So, instead of valuing up to 100 harmonics, I'm only going to do 20. Alright. Oh, no, wait, it's the printfs. My bad. Alright, there we are. Ah, shoot. Alright, so what I was attempting to doing now is adding a little bit of vibrato to the note. So vibrato is basically a little flutter in the frequency. Something like that. But what's happening is the vibrato just goes out of hand. So if you listen to this, right? Shoot. I mean, you could just hear it. It's just going. So I'm trying to fix that. I believe I'm just calculating vibrato wrong. So I'm just going to get my textbook out here and double check that. Or you know what? This might be a good chance to show off a little bit of documentation I've been working on. I think I wrote something. Oh, I gotta make it. Okay. Yeah, I wrote a section on vibrato. I need it. In any case, while I'm waiting for those to install, just sorry again for some of these technical issues. I've been trying to use OBS, but OBS on Linux is still a little buggy. Experiencing some crashes and that. All right. BD to sine 2 pi. Okay, that's not right then. F plus V sine 2 pi. Depth sine 2 pi t. Yep. Maybe I just have the values too high. That may be it. All right. So let's try these numbers out instead. Alright, that's like a little better. I think maybe I just had the rate and depth a little bit off. Let's do a little bit faster rate. Let's try 5. Of course. Yes. No, it's the same issue again. It just keeps compounding like that. All right. Just for fun, I'll show you what happens when you get up into the audible range for your vibrato. Oops. Oh, come on. So that's a form of FM synthesis, frequency modulation. I will be adding an FM synthesizer proper to Jubal eventually. But for now, I have a little bit of a. It seems I have a little bit of a conceptual misunderstanding of how it works, or how vibrato works. So I'm just going to disable that for now, and instead I'm going to add tremolo. So tremolo is kind of like vibrato, but it only operates on the amplitude, not the frequency. So it would be something like like a little bit of a fluttery sound, but more of the amplitude. So when we are calculating the value, we need to mix by the tremolo. Right, so the tremolo will be also a sine wave. The depth, sine 2 pi theta tremolo rate times t. All right. And I will just add those things to here, to the structure. And make sure to initialize them. Let's say 6 hertz. All right. So now you can hear this is the sound. That's a little bit an extreme example, maybe. So we'll reduce the depth a little bit so that it does not have as much of an impact. Let's try 0.25 maybe. Oh, I see what. When we are mixing it like that, I think we should just be adding it. Adding it to this mix value. Oops. And we'll make it a little bit lesser depth, I think. And maybe a little bit faster. Ah, shoot. Okay, come on. All right. Let's do a little bit more. As you can see, there's various different effects you can reach depending on how you use it. So just for fun, I'll show you what happens when you increase the tremolo rate into the audible range. So that's another effect. Once it gets up into that range, that effect is called amplitude modulation. And I will be adding amplitude modulation to Jubal eventually as well. Suppose the next thing we can add, I'll just turn the treble off for now. Eventually, in order to control all these parameters, like the tremolo or the vibrato, they will have parameters. Each one of these things will have parameters that can be adjusted either in an editor or programmatically throughout the song via the sequencer. So right now what we're going to do, we're going to add an envelope. So basically an envelope is, it shapes the amplitude of the sound as it goes throughout the cycle. I'm going to do a 4-stage envelope. Actually, no, I'm just going to do 3 stages for now. Attack, sustain, and release. So basically, when a note is in the attack phase, so maybe I'll draw it. Alright, so we have the attack phase, sustain, and release. So attack phase is basically how long from when the note is triggered until it reaches its sustained volume. So this is, if you think about, like a piano or something, when you hit a key, the time until it's got a very short attack. But if you think of like a stringed instrument, it takes a much longer time to go from when you start bowing the string until it gets to its maximum sustain value. So then the sustain value, I've got to make this a little smaller, I think. I'll draw an arrow here. Whoops. That's not good. Alright. So this is when the note on event is. I just pretend like those match each other. Alright? And terrible. Here, once the user does, or the musician does a note off, then we enter into the release phase. So the release phase is just basically how long does it take to fade to silence after your hand leaves the keyboard, or other equivalents for a different instrument. So I'm just going to do a simple attack, sustain, 3-stage envelope, attack, sustain, release. So we have the time until we go from attack to sustain phase. We have a sustain, which is a level, and we have the release time. And depending on those values, things will be changed. Alright, so I'm going to make one with a longer attack time. Let's give it half a second. Uh, 1.0. And let's give it a fairly long fade out time as well. So when we are evaluating the notes, we have to take the time and determine which phase it's in. Of course, there are obviously more complex envelopes, and eventually I will be adding those to Jubal, but for now I'm just doing attack, sustain, release. Alright, so for this one, basically we want to linearly scale. I'm going to, there's other interpolations you can use, logarithmic, you know. So this one, we're just going to go linear, but you know, you could do like a logarithmic type 1. Or like an exponential. Or a linear. Terrible handwriting, but hopefully you can see. These are different kind of interpolations you can do, and it changes the sound of the envelope applied to the synthesizer. So right now we're just going to start off with linear. Alright, so there's different ways you can do this. Right now we're just going to hard code the start of the attack to be 0, so it's always going to fade in. You know, obviously once you get more sophisticated you can have a non-zero start, so if you wanted something that starts out loud and then gets quiet at the sustain phase, that is also possible. So the rise is going to be 0 to data sus level, and the run from time 0 to data 80k time. So actually we didn't even need that, because it's just, you know, -0, but you know, we'll add to it eventually. Okay. So by default, the amplitude for the envelope will be set to the sustained level. Otherwise, if we're still in the attack phase, then set it to a linear interpolated value on that line from attack to sustain. And we also have to know if it's in the release phase. So I'm not going to do release for now, actually. I'll come back to that. I need to add another variable that's set, because release is only done when we're in note off. Alright, so I'm just going to add another variable for that. Actually, we're just going to check for note on. Actually, I got to think about this a little bit. Yeah, we'll just not do that for now. We'll come back to it. Alright. I made a mistake. Yes. Alright, so now you can hear when I play a note, you listen, and you can hear how it takes longer to fade in. Alright, we've been using the saw patch a little bit long, I think. Let's mix things up. To make a saw wave, we just evaluate the Fourier series for each harmonic. Harmonic is just an integer multiple of the frequency, and then we divide that harmonic by that same integer multiple. Alright, so that's how you do a sawtooth wave. Square wave is very similar, except you only do the odd frequencies. So here I change it, and now we'll have a square wave. And let's make it take a little bit longer to fade in than half a second. Let's make it take, I don't know, how about 2 seconds to fade in. It might be a little slow. No, it's not working. Come on. Right. I'm going to change it to 1 second. Alright, so that's the basic idea behind envelopes. Obviously, there are more stages which you can add to your envelopes. So I'll just show you an example of a little bit more advanced one. I'll show you DADSHR envelope. Alright, so that basically is like this. I'll change the color just so you can. Alright, so the first phase is it's terrible. The delay. Alright, so the delay is, you know what, I'm just gonna show you this. So this is when the note on event occurs, and this is when the note off event occurs. Alright, so the delay determines how long it is until the note, from the note when the note is played until it enters into the attack phase. And there's one parameter here, which is the time. Alright, and then next we have the attack phase. Alright, so this is how long it takes until we reach the next phase. And attack, which I was explaining, that's one of the key ones which we just added to our envelope, which we just implemented earlier. And the main parameter here is the time, which is how long it takes to go from here to here. And we also have another level parameter. I'll do an L, which is where this point here is initially. All right, now we have the decay. So decay is how long it takes to go from the attack peak here down to the sustain level, and this is time parameter. Then we have the sustain level here, S. And sustain level is just a volume, so that's pretty much what's the volume going to be during the steady state. Then once the note off trigger is received, we will enter into the H stage. So H is hold, and that is how long after note off do we hold it at the same volume. And this is a time. No, you can't see that. And because the level is going to be the same as the sustain level here. And then finally we enter into the release phase. which is essentially the time it takes to fade out into 0. So this here is a D, A, D, S, H. Yeah, this is a DAD SHR envelope. That's delay, attack, sustain, hold, release. And there's various things you can do. You can leave out various components. You can add more. Typically, once you begin to have more classic ones, then some synthesizers, they just do like you just have an arbitrary amount of points, and you can just set them up and be triggered at any point in the sequence. Another common one is A, D, S, R, which is attack, decay, sustain, release. So that one is basically not doing the delay or hold parts of the envelope. This one is also pretty popular and pretty common. Okay. So our synthesizer is a little bit here. Some other things we could improve. We could add the envelope. Actually, let me see. There's some other effects I've already worked out. We did tremolo. We did vibrato. Oh yes, portamento. I guess we can try and do this one. So basically, portamento is kind of a way which you can just slide the note. So instead of making the frequency change immediately, you kind of interpolate between the two frequencies. And you can do that in exponential, logarithmic, linear, etc. I'm not sure if I want to add that right now, though. Well, I guess I'll add the parameters for it. If you're wondering what this document, I keep kind of going back here. This is basically the Jubal manual. Spacing's a little bit messed up here for some reason. I think I don't have the right installed. No, it's already installed. Whatever. Some of the spacing's a little off, but whatever. Alright. You know what, I'll just move that over here. Whoops. Alright, now we will add portamento. Whoops. Shoot, I have caps lock on. Alright. You don't want to turn caps lock on by accident when you're using Vim. Otherwise, all your commands, don't do what you expect. Alright, so this will be done at the triggering time here. Go to Jubal. And just like we had that, whoops. Just like we have this if-else here for determining which phase of the envelope we were in, we will have a similar branch to determine which phase of the portamento we are in. Whether we are in the slide phase or the steady state phase. So if the time is less than the portamento time, and we need to adjust it by the portamento rate. And this is another linear interpolation here. All right, good. And now let's try and come up with some good values for these. All right, so this should be port time instead of port rate. So let's make it slide in. Let's increase the attack time. Okay, let's say 0.1, just to make it come in a little faster. And let's say we want to make it slide in for a quarter of a second. Let's do half a second. We want to at depths, let's say 100 hertz slide in. Made a mistake. Oh, of course. These need to be in data. All right, so. That's a little abrupt, isn't it? I'm thinking I made a mistake somewhere. Alright, here's less than data, port time. F equals F. Well, let's just separate the components a little bit, make sure we didn't make a mistake. Alright, so the rise is going to be from the frequency to The final destination is the frequency before it's going to be the frequency plus the portamento depth. And then the run is going to be from 0 to the portamento time. Slope is rise over run. And if it's going to be slope times time plus y-intercept. Let's try that. Oops. Come on. Alright, I may have made a mistake here. Let's see. Come on. All right. Okay, so that should do it. Nope, come on. All right, that's kind of what we were going for. It's almost right, not quite though. What it's doing is it's going down, it's jumping up, but it should be starting higher and going down like that. But we are close. I just got to check this calculation. Pardon me a second here. Okay. You got this. Just change the direction here. The slope. Not quite. Almost. Okay. So the sign here needs to be changed so that they'll cancel out. Alright, this should do it. Alright. Shoot, come on. And let's make it maybe a little bit less crazy here. Something like that. I think that the linear interpolation sounds a little bit off. Transitions into the steady state. I'll have to do some more experimentation to find maybe a better way to interpolate for that. Come on, OBS. Alright. Just a little bit of tweaking on OBS. Yeah. Maybe we'll change it back. Sawtooth might sound a little better with that. Alright, that's pretty much all the tricks I have planned of kind of showing off for the synthesizer. Again, the basic versions of most of them, I think. So that's pretty much all I have prepared for this demonstration for the stream. Very sorry about all the technical difficulties that came up with, OBS crashing partway through and setting it up, but hopefully it was worth it to be able to kind of hear what Jubal sounds like. So yeah, that's pretty much all I have for today. Thanks you to sorry about that. Anyway, thanks to everyone for watching. I'll go ahead and push some of these changes here, and then you can review them on GitHub once this stream goes offline. Shoot. Okay. Already started that. Alright, great. Alright, so that's all the changes I did. They're all up on the GitHub, which you can see the link to in the video description. Thanks for watching, everybody. That's all I have for you.